Hey guys, this is Miss Goodson. I'm just going to show you or do a quick video to kind of talk about how you're going to be completing this lab activity in case you are not in class when I go over it, or if you don't remember how to do it when I did go over it in class. I know it's really dark. I'm hoping that you do not see this big old glaring thing in the middle of the United States, but I think that you are. So I'm going to try to deal with it. I don't know how to get rid of it. I've tried doing lots of different angle things and nothing is working. So I'm just going to kind of roll with it. But anyhow, so let me go ahead and get back to talking about isotherms. All right, so with isotherms, it's going to help us to identify warm and cold air masses. So isotherms is going to be talking about the temperature, but we're going to be talking about isobars, which is going to be talking about your high and low pressure systems. All right, so you're going to be practicing drawing isotherms and isobars and locating the different types of air masses. Okay, so I'm going to go ahead and just kind of read through here, and I'm going to probably have to scroll up a little bit. I can't do too much, or else it's going to be on the wall. All right, so what you're going to be doing, okay, I'm going to read what it says, and then we're going to kind of do it together. So it says on map A, this is map A, that there is a 2-degree interval is going to work best. So you're going to find a station where the temperature is 13 degrees. So it says starting at that point, draw a light line to show where 13-degree locations would be. So remember, if there is not a 13-degree location nearby, you're going to draw halfway between the 12 and the 14-degree stations. Then you can continue the line until it has gone through all the stations and all the locations that are 13. So it says your line should form a closed loop. Okay, darken your line when you are sure it is correct. Okay, so we're going to start with 13. So, all right. I'm going to do it, let me do it in a different color. I'm going to do it in blue. All right, so here's 13. Okay, so you can see I have a 13 here, and I'm going to basically, it's like connect the dots. So here's a 13, here's a 13, here's a 13. Okay, I have a 14 here, 15, 15. Okay, I can't go above it. So here's a 13 here. Okay, here's a 13 here. All right, I have a 13 here. And I have a 13 here. So this is what they mean by a closed loop. Okay, everyone see that? I hope that shows up. All right, then you're going to do the same thing where it says for 17, 19, 21, and 23. Okay, so let me look for 17. Some of these are going to start to get a little trickier. They're not going to be as easy as the 13 is. So let's just do 17. So I have a 17 here. And remember, I can't go past it. So here's a 19. So it's not going to go this way. All right. So let me see here. I have a 17. Here's a 15 and a 19. So it's going to be between these two numbers. I'm looking for a 17. Here's a 17 over here. So I kind of want to go from here to here to here. Okay. So I'm going to draw my line here. I'm going to bend it a little bit. And there's my 17. All right, here's a 16 and an 18, so it's going to go between these two, and I'm going to go up to my 17. Okay, here's a 17. Here's a 17, here's an 18, so it's not going to go this way. It has to go before it. All right, I have an 18 here. 19, 20, I don't see any other 17s. So this is as far as it can go. So this is what they would consider to be not closed or that it is open. So there's my 17. Okay, here's looking for 19. So here I have a 19, 19. Okay, I have a 19 here, so it's going to go between my 17 and my 21. I have a 19 over here. So I can't go this way because it's going to be up too high, so I have to go before it. All right, I have a 20 here, a 19 here. So it's going to go around to the outside edge. All right, 18. Here is a 19. And here there's a 20, and I can probably go that way. Okay, so I would say that one is a closed loop. All right, let me do the same thing for 21. So here's 21, 21. I have a 21 over here, 21, 21, 21, and 21. So that one is closed. Next one is a 23. All right, so you can see that that one is a closed loop. All right, so then you're going to go through the questions, and then you're going to just answer the questions. All right, so they're asking us, would it be a closed loop or not? Okay, if you had 15, so here they had done the 15s, is that a closed loop? So that would not be a closed loop. Okay, so go through and then answer the questions, but this is how you're going to be filling them out. All right, this one is pretty easy. Okay, the one that we're going to do together. But they do get a little bit harder, a little more complicated. I'm going to erase it, and I'm going to show you some of the other ones, other pitfalls that you may run into. Get my mouse to work. Okay, so those are the questions that you're going to answer. So here what they're doing on this one is going by tens, but you can see you don't have nice, easy numbers. So when you're going by tens or 20s by 30s, you're going to have to do a lot of approximate. Where is it going to be? All right, so that's for that one. Okay, this one, you can see that you're going to be looking at high pressure and low pressure. So again, you're going to do the same thing, but you're talking about the millibar, where you're talking about these numbers. So where you're 1,000, 1,004, 8, 12. Same concept. You're going to be drawing them in and deciding whether or not they are closed or an open loop. All right, same thing for map D. Okay, so read the directions. We're talking about high pressure and low pressure systems. And you do not have to do this last page on page 5. Okay, so you are just doing the maps. So I hope that this helps explain how to fill out the isobars. Hey guys, this is Miss Goodson. I'm just going to go ahead and I want to explain how you guys are going to be filling in for the relative humidity. So when you're going to be opening this up in Cami, but I do want to explain how you're going to do this. So in case you are not in class or don't understand, that you can go back and view the video, and then hopefully it will make more sense. All right, so in order to find your relative humidity, there's different things that you're going to be looking at. You have an air temperature. If you see, follow my mouse. You have the air temperature. It's always done in Celsius. You have a wet bulb temperature, and then you're going to be having a dry bulb, okay? And in that case, I said you're going to be looking at the difference. So basically, you're going to be looking at the difference between your air temperature and then your wet bulb temperature. And then difference just means that you're going to be subtracting. Then you're going to be filling in the relative humidity, the percent of that. And then your dew point is also going to be in degrees Celsius. So where you're going to find this information here for the percent for your relative humidity and your dew point, you're going to scroll down, and then it's going to be on the next page. So here you're going to be finding out for your dew point, which is in degrees Celsius. And then this is going to be for your relative humidity. Okay, so in order to find, before we can go ahead and do the dew point, let me go back, is that you can see there's a wet bulb temperature. And then here for the difference, that is going to be your dry bulb temperature. So if you look for your dew point, okay, you're going to be looking for the difference between the wet and the dry bulb. And then this is going to be for your dry bulb temperature. Okay, So let me go back. And if you scroll, hang on. Like I said, I just have two screens pulled up. So let me get back. Okay, there's the chart. So here what you're going to do is find your air temperature and then the difference, okay, between, and your air temperature, that is going to be your dry bulb temperature, and this is your wet bulb temperature. So I'm going to take 24, take away or subtract 16 is then going to give me 8. So hang on, I need a text box. So it's going to be a difference of 8. Okay, so you're going to do that for all of them. I'm just going to go ahead and do one other one. Okay, so I have my 8 here. And then in order to find my relative humidity, I'm going to go to my chart. So here you can see the difference between the wet and the dry bulb, right? That one was 8. And then my dry bulb temperature, I have to go back to my dry bulb temperature was 24. So then on my chart, I'm going to go down to 24. I'm going to scroll over to 8. And so I'm going to see my number there is going to be 10. So I go down to my air temperature, or my dry bulb temperature, which was 24. I'm going to go over to the difference, which was 8. And so that is going to be 10. So that is going to be my dew point. Okay, and I need to go over here to find my relative humidity. So I'm going to do the same thing. So my relative humidity, again, is a difference. So it's going to be 8. I'm going to go down to where it says 24. And here it says 42. So I'm going to go back over here. And it's going to then be 24%. Because remember, relative humidity is always going to have a percent. Okay, and then remember, this is going to be in 10, it's going to be degrees Celsius. Okay, so that's how you're going to figure those out. Subtract your two numbers. That's your difference. You're going to find your difference to find your relative humidity, and then also for your dew point. Okay, so I hope that helps to explain how you are going to fill out for the relative humidity workshop.